And let's try to solve another hydrodynamics problem. Sabi sa problem na to, a jet of water with velocity of 35 meters per second strikes a series of radial curved veins of wheel rotating at 250 rpm. The jet makes an angle of 20 degrees with tangent to the wheel at inlet and leaves the wheel with a velocity of 10 meters per second at angle 130 degrees, tangent to the wheel at outlet. Water is flowing from outward in radial direction. The outer and inner radii of the wheel are 0.5 meter and 0.25 meters respectively. Determine first the vane angles at inlet and outlet. Second, the work done per second per kilogram of water. And third is the efficiency of the wheel. So we have here our illustration for a series of radial curved veins. So draw natin ngayon yung mga velocities and yung mga given sa ating problem. So this is now our illustration for this specific problem. So let's try na ilagay yung mga given natin. So ilagay natin ngayon yung ating mga given. So this is our point 1. For point 1, itong ating velocity 1. This is our u1 and this is our v1 normal. So, ang V1 is directed here. And ang U1 is directed also upwards. V1N, directed upwards. And then, yung ating horizontal velocity, this is our V1 prime. So, binigyan tayo ng angle ng jet of water at inlet. So, that is 20 degrees. So, this one is 20 degrees. And then the wheel is rotating at 250 rpm. So our N is equal to 250 rpm. So at point 2, binigyan din tayo ng given. So it leaves the wheel with a velocity of 10 meters per second. So the jet of water is leaving at 10 meters per second. So nag-decrease siya ng velocity. This is our V2. And at an angle 130 degrees tangent to the wheel at outlet. So ito raw ay 130 degrees. This is 130 degrees. But since ito ay right angle, i-minus natin yung 90 degrees from 130 degrees. So mag-arrive tayo sa measure ng angle na to, which is 40 degrees. If this is 40 degrees, therefore this angle is 50 degrees. So ito ay right angle din. So if that is our V2, therefore this is our U2 directed towards the upper right, and then this is your V2 prime. Ayan. So kung ito yung ating V2, therefore itong line na yan, yung velocity na yan ay V2x. And then this one, yung velocity na to, this is V2n. Let's see, that is V2n. Now let's try to list all our given and the unknowns. So V1, that is 35 meters per second. N is 250 rpm. So ang angle ng ating jet at point 1 is equal to 20 degrees and leaves the wheel with a velocity of V2 is 10 meters per second at an angle 130 degrees. is 130 degrees. Outer and inner radii of the wheel are 0.5. So, ang tinutukoy na dun ay radii ay yung measure from the center to this point and to this point. Ang outer radius is the radius at point 1. So, ilalagay natin R1 is equal to 0.5 meters. And then, yung other radius, which is 0.25, that is the inner radius from the center. So, ang tinutukoy niya na radius ay 4.2. So, for R2, yung ilalagay natin is 0.25 meters. And then, ang mga unknown natin is the vane angles at inlet and outlet. So, ang vane angles are the angles na ating relative velocities u1 and u2. So, that is theta u1 unknown and theta u2 is also unknown. Work done per second per kilogram of water. So, yung work per second per kilogram of water. So, dito, take note na binigyan tayo ng kilogram of water. So, let's treat that as mass flow rate. So, that is mass flow rate, which is per kilogram of water. So, assuming 1 kilogram of water per second. And then, third is the efficiency of the wheel. Efficiency is unknown. So, now, let us actually try to solve this problem by starting at point 1. So, since given ang angle natin for V1, we can compute for V1x. Then, i-minus natin yung V1 prime galing dun sa na-solve nating V1x. So, to solve for V1x, that is V1 cosine 20 degrees. So, that is 35 meters per second cosine 20 degrees. 35 meters per second cosine 20 degrees is 32.89 meters per second. So, mula rito, ima-minus natin yung ating V1 prime. But first, let's try to determine what is our V1 prime. So, V1 prime is the linear velocity of our angular velocity. So, meron tayong binigay na RPM, which is 250 RPM, and binigyan din tayo ng radius. So, using these values, we can determine the linear velocity of the angular velocity at point 1. So, to solve for V1 prime, ang ating solution is 2 pi rad per rev multiplied to n and R1. So, nilagay natin ito para makita ninyo yung cancellation of units. So, 2 pi rad over 1 rev. This is 1 revolution times the n, which is 250 revolution per minute, times the R1, that is 0.5 meters. And then, convert na kaagad natin to into seconds. So, that is 1 minute over 60 seconds. So, revolution, magka-cancel. Minute and minute. So, itong rad, kapag minultiply natin yung meter, magiging meter per second na lang siya. So, the answer for our V1 prime is 13.09. 13.09 meters per second. So, to determine the x component of our u1, we will subtract yung v1 prime sa ating v1x. Kasi, ito, yung ating v1x, this is our v1x, yung total niya. Kasi ito ang v1, and ang component niya at x-axis is this one, yung kabuuan na to. So, to determine the u1x, That is v1x minus v1 prime. So to solve u1x, that is v1x minus v1 prime. So that is 32.89 meters per second minus 13.09 meters per second. Now, our u1x is equal to 19.8 meters per second. Meron ka ng x component for our u1. Ngayon, using v1 again and the angle of our v1 at inlet, pwede nating ma-determine yung v1n, which is also equal to u1y. So to determine our v1n or our u1y, our formula is v1n v1 sine 20 degrees. So that is 35 meters per second sine 20 degrees. Now that is equal to 11.97. 97 meters per second. So using the values for u1x and v1n, we can now solve for the vane angle at point 1. So this is theta u1. So to solve for that, ang formula natin is tangent theta u1 is equal to opposite, which is v1n, over the adjacent, which is u1x. So to solve for theta u1, we need to rearrange this equation into theta u1 is equal to tangent negative 1, or that is arctan, v1n over u1x. So applying the values for v1n and u1x, that is 11.97 meters per second over the u1x, which is 19.8 meters per second. It is equal to 31.15 degrees. 15 degrees. Now, meron na tayong answer for the vane angle at inlet. So, isupply natin itong nakuha nating value for vane angle at inlet sa ating unknowns. So, that is 31.15. 15 degrees. Ngayon, punta naman tayo sa point 2. Let's try to solve the v2n and v2x para ma-solve natin yung y and x component ng ating relative velocity at point 2. Then we can also solve for the vane angle at the outlet, which is the angle of our relative velocity at point 2. So first, let's try to solve for v2n. So the formula for v2n is equal to v2 sine 50 degrees. So v2 is 10 meters per second, then sine 50 degrees. That is equal to 7.66 meters per second. We can also solve for v2x. But since v2x is directed towards the left, so ibalik ulit natin yung ating coordinate plane. So this is positive y, this is positive x, this is negative y, and then this is negative x. So since ang ating v2x is directed towards the left, this is negative sign. So that is negative v2x. So negative v2x is equal to v2 cosine of 50 degrees. Now in order to make our v2x positive, the value ng ating v2x positive, ilipat lang natin yung negative sign dito sa kabila. So, ang process nun ay magmumultiply ka ng negative 1 dito sa left side and magmumultiply ka rin ng negative 1 dito sa ating right side. So, kapag nagmultiply ka ng negative 1 dito sa ating left side, magkakaroon ka ng positive v2x. And kapag nagmultiply ka ng negative 1 dito sa already positive value, magkakaroon ka ng negative value. So, v2x is equal to negative, ano yung V2? That is 10 meters per second cosine 50. So that is negative 6.43. Negative 6.43 meters per second. So kanina, kinuha natin yung V1 prime. Ngayon, it is also necessary for us to get the value for our V2 prime dahil magkaiba yung radius ng ating inner and outer radius. Therefore, mag-iba rin yung kanilang linear velocities. So to solve for V2 prime, kagaya lang din ng formula kanina for V1 prime, that is 2 pi rad over 1 revolution multiplied to your n and to your r at 2. So that is 2 pi rad over 1 rev times your n, which is 250 revolutions per minute, times your r2, which is 0.25 meters, and then convert natin yung minute into seconds, so that is 1 minute per 60 seconds. So to perform cancellation of units, so yung revolution natin magka-cancel, yung minute as well. So pag multiply natin yung meter into rad, magkakaroon ka ng meter per second. So that is V2 prime, the linear velocity of the angular velocity at point 2. V2 prime is equal to 6.54 meters per second. So now to solve for the x component of our relative velocity at point 2, that is u2x, we need to add v2 prime and our negative v2x. So that is v2 prime plus the negative v2x. So that is 6.54 meters per second plus the negative value of our v2x, which is negative 6.43 meters per second. So this signifies na in-negative yung value ng ating v2x, and since the magnitude of our v2x is negative 6.43, nilagay natin siya dito. So this one, so negative multiplied to the negative value of our v2x, this will result into a positive value, and then mag-add siya sa 6.54 already. So that is 12.97 meters per second. Now to solve for the vane angle at the outlet, or the angle of our u2, we can use the values of our u2x and the v2n. Kasi yun yung x component and y component ng ating relative velocity at point 2. So to solve for that, our solution is tangent theta u2 is equal to opposite, which is v2n, over adjacent, which is our u2x. So to solve for theta u2, relative velocity at point 2, we need to rearrange this equation into u2 is equal to tangent negative 1, or arctan v2n over u2x. That is tangent negative 1, supplying the values of v2n, that is 7.66 meters per second, over the u2x, which is 12.97 meters per second. Magkakancel yung mga units na to, matitira ay degrees. That is 30.57 degrees. So we now have an answer for the vane angle at the outlet. Supply na natin siya dito sa ating table. So that is 30.57 degrees. Now, in order to solve for work, our formula is f of x v prime. But since wala pa tayong f of x, we need to solve for this first. The solution for finding f of x is equal to rho, volume flow rate, density, volume flow rate, V1x minus V2x. But since we know na ang density is equal to mass over volume, kapag pinag-multiply yung density and volume, magkakaroon tayo ng mass. And if the volume is a flow rate, therefore, the mass is also a flow rate. So that is rho V flow rate is equal to mass flow rate. And we are given the mass flow rate of 1 kilogram per second. Actually, this is an assumption. So, in-assume lang natin yung mass flow rate ng ating problem ay 1 kilogram per second. That is, f of x is equal to, so, this one is considered na mass flow rate. So that is mass flow rate v1 of x minus v2x. So that is 1 kilogram per second multiplied to the quantity of v1x, 32.89. So that is 32.89 meters per second minus v2x. So the value of our v2x is negative 6.43. So that is negative 6.43 meters per second. Close your quantity. So since this is negative, multiplying to a negative value as well. So magkakaroon tayo ng addition na dito ng value. So 32.89 meters per second plus the 6.43 meters per second multiplied to kilogram per second. So f of x therefore is equal to 39.32 Newton. So paano naging Newton? Kilogram multiplied to meter per second squared. So second times second, that is second squared. Kilogram meter per second squared is Newton. So this is now our f of x. Using the value of our f of x, we can now solve for the work. So this is 39.32 Newton multiplied to v prime. But since we have two linear velocities, i-minus lang natin yung second linear velocity, which is the v2 prime, from the first linear velocity, which is v1 prime. Kasi mas maliit yung value ng ating v2 prime compared sa v1 prime. So that is v1 prime minus v2 prime. So now to solve for our work, that is work is equal to 39.32 Newton multiplied to v1 prime, which is 13.09 meters per second minus v2 prime, which is 6.54 meters per second. 6.54 meters per second. The value of our work is 257.55 watts. 257.55 watts. So, paano naging watts? That is Newton multiplied to meter, that is Joule. Joule per second is equal to watts. So, this is now the value of the work. So, supply natin ngayon yung value ng ating work dito sa ating table. That is 257.55 watts. Napagkasyahin na lang natin dito yung ating solution for our efficiency. So, the solution for efficiency is work over kinetic energy in. So, that is work over 1/2 mass flow rate V1 squared. So, that is 257.55 watts over 1/2 mass flow rate, that is 1 kilogram per second times V1, that is 35 meters per second. 35 meters per second quantity squared. So this will result to a unitless value kasi magka-cancel yung ating watt. So paano magka-cancel? Watt is equal to Newton meter per second over yung ating units na nasa baba, that is kilogram per second meter squared second squared. So ito magka-cancel, ito ay magka-cancel. So, magkakaroon ka ng nag-iisang M dito. So, magkakaroon ka ng Newton per kilogram meter per second squared. Kilogram meter per second squared is also equal to Newton, 1 Newton. So, magka-cancel yung mga Newton. So, ito, unitless yung value natin dito. Then, i-multiply natin sa 100 para makuha natin yung efficiency. The value for our efficiency is 0.4205. Multiply natin sa 100, so that is 42.05%. So, this is now our efficiency. So, supply lang natin siya dito sa ating table. So, 42.05%. So, that's it for this problem. Ayan, i-zoom out ko lang siya para makita niyo yung kabuuan ng ating solution.